Hi, my name is Akhil Vaid, and this is my final project for intermediate Python. Uh, so what I sought out to develop was a trading engine server, which started out as a trading engine server, but then I morphed it into an order book implementation. And what's interesting about an order book implementation, why I chose this is first, I've been interested in financial code development. So this was one of the first projects I wanted to develop, especially using Python, because I wanted to try out threading in Python. Not that I use a lot of threading over here, but I do touch it. And an order book to be efficient requires a good amount of implementation uh, to have insert delete operations take login time. So let's get into it. Uh, I'm going to follow the rubric because I understood that it takes a lot of time to, I might take more time. So I'm just going to go over these 3 points for around 5 minutes each. So I'm going to talk about what the research problem was. So I've linked a description of the problem statement over here. Basically, we're going to simulate a market where people raise bid orders and ask orders. And if someone is bidding $5 for 100 shares, that means if I was to sell 100 shares right now, I would earn 5 into $100, which is $500, right? And similarly, if someone had an ask order in the market, which is basically asking for, let's say, $3 for 100 shares, then if I wanted to buy 100 shares from that guy, it would take me 3 into $100. I'd have to pay him. So our problem statement in a crux is that we're given a target size of shares, let's say 200 for our case, and we have a stream of add orders or reduce orders. So an add order is basically a bid or an ask, and a reduce order would reduce the size of either the bid order or the ask order. Just simple. And at any given point, if the target size is 200, if the amount of bids go above 200, then we want to calculate the amount of income we can generate if we sold 200 shares at that moment, and vice versa. So what you want to do is you want to keep a descending sorted uh, sorted implementation of your order book, which is basically a book of bids and asks. And what you're going to do is at every moment you're going to calculate if the total size of the bids is greater than the target size, then you can output how much money you would have generated if you sold those many target size shares. And similarly for asks. So I'll show you how this looks like in the code. So I'm going to start a new trading engine server. Okay. So when we start a trading engine server, I'm just going to delete these two. They are artifacts. When you start a trading engine server, when you start the project, then it will create two log files. One is the main log file and the other is the order book log file. So you can see the time is around 6 p.m. right now. So it just created a main log file with the name as the time, and you can see nothing's present right now. What I'm going to do is I'm also going to show you the order book. So currently the order book looks like this. There are two threads in the program. There's a main thread and an order thread. So the order thread waits for orders to be present in the orders file as text files. It will process them and move them to the processed orders folder. And the main thread is responsible for sleeping every 1 second and outputting what the order book looks like at any state. So if I move, so if you see the operations in order1.txt, if I move this into orders, then our main log file is going to consume those orders. There were 3 orders, add, reduce, and then it will process them and move them to the processed orders folder. So it takes a little time to update, but they have moved over there. And currently our order book would be updated to look like this. The size is 0 for the asks because there is an add order for 100 size and a reduce order for 100 size. So basically the size is 0 now. Similarly, if I move these orders into our program, then you can see our order book changes. The order book for bids is always in descending order of prices and asks is always in ascending order. Similarly, I'm going to move all of them. And what you can see is that we get the correct output as we'd want in the HTML file I showed you previously. So, for example, one output I'd show you after 4 orders, it tells us that for the timestamp this, we can sell 200 shares for $8,832. And that's the first output over here. Okay. Now I want to spend some time walking us through the code and showing us how it works. So let's go to the trading engine server directory into tradingengineserver.py. So basically we're running this this file, and what it has is basically there's this class trading engine. It has a lot of member variables. The first is an order book, which is implemented in the pricer.py over here. So we'll look at that in a second. We store the main log file and the order book log file as the current time appended as a suffix. We have the folder, the file. We have 2 threads, the main thread and order thread. And I also implemented a logging feature similar to a logging framework you'd have. There are info, error, debug, warning, log levels. I mostly use info and error over here. Let me take you down over here. So we initialize an object of the trading engine and then we start it. For start, it will start both the threads. So let's go into the main thread. The main thread's main loop, it prints the info log level, and then there's an infinite loop, not an infinite, it's waiting on this exit flag, and it will sleep for every 1 second while printing the order book, which I showed you earlier, which contains the bid book and the ask book. Similarly, let's look into what the order thread does. So the order thread, it will keep reading any files, text files, which are created in the orders directory, and it will pick up that order.txt. It will read the individual orders in it after splitting and doing some string cleaning, and it will check if the arguments are correct, the length of arguments. If they aren't, then it will create error log lines. Again, this is all a custom logging framework I wrote, which took some time, but I really liked it. It will process the order. So the main logic is within the processing the order step. So the order book, which was initialized as a member variable, that has 2 functions, either process add order or process a reduce order. The functionality for an add order is present in the pricer.py, where we have 2 sorted dictionaries. So the bids and the asks are basically a sorted dictionary, and a sorted dictionary is based on a red-black tree implementation. So I'm going to take a moment to discuss the trade-offs as well. while implementing this. So one of the bigger orders which came in, the big order.txt, this has a size of around 28 megabytes, and it has around 1 million operations. So to efficiently perform an add order and a reduce order, I decided to use a red black tree implementation, which is provided by the SortedDict from the sorted containers module. And uh, this will help us maintain it in a sorted fashion. And an insert operation takes O of log n time, and a removal would take O of n, because we wouldn't know where to remove from because we only have the order ID. So a reduce order would try to reduce from the sorted dictionary. So to get over this problem of ON, we use another dictionary which stores the price associated with any order ID. So now we can directly look into our dictionary and decrease the size of an existing bid or ask at any time in O of 1. And if there are multiple orders which come in with the same price, so the same price things are stored such that if I can show it over here. So if you have two orders with the same price, 44.18, then they are so they are clubbed together as a dictionary, actually. Uh, so so this helps us with maintaining our O of 1 structure for lookup and reducing as well. And in the worst case, it would be O of n for reducing an order. No, it wouldn't be O of n, because you go into the price of 44.18 and then you change the size of the of the order ID. So it's really interesting how we could land on an O of log n and O of 1 implementation. I'll write up a little bit more about the time complexities in the README file. Going back to our trading engine server.py, yeah, and then you'd want to calculate the expense income at every point if the total bids or total asks go above your target size. And that is done in this file in the pricer.py. Yeah, and if it goes above, so I keep two variables for the bids total size and the asks total size. If they ever go over the target size, then you can start removing the optimal orders using the amount of shares they are either selling or buying. And with that, you can calculate your income or your expense. And then you send that income and expense back. And yeah, you can then log it as I showed to you before. So yeah, I think that covers most of it. I also want to show you the logging facility I wrote over here. There's an abstract logger. I initially planned to write a database logger and a file logger, but I think that can be part of a future scope. Right now, I'm just writing into a text file, but I think that the size and scale of this project is really fascinating. We're able to implement a lot of this in really good time complexity, but I think the bottleneck right now is the logging, how much time it takes for our hardware input output to write into files. And I'd love to discuss methods how logging frameworks are able to reduce that time. Yeah, and in data.out, we have three log files, which are basically the outputs for what for the corresponding target size. So this output for pricer.out.200, you can compare this with what you'd get after you process the big order.txt by placing that in the orders folder. And yeah, it would be the same. Uh, yeah, and I think that sums up what this project is. There's a lot of scope in in improving this. The main challenge was that multi-maps do not exist in Python as they do in C++, and I think I implemented a really good working implementation of multi-maps as an order book. And yeah, I think this can be extended into a bigger and better project. Uh, the video goes a little long. I think we're going to hit 16 minutes. I'm going to cut off here. But I felt this was a good spend of time, and I really enjoyed the course I took this semester. So thank you. And if you have any questions, please reach out to me. Peace.